Let's take a look at hanging mass problems. Let's say we have a mass M that's suspended by some cord, and let's analyze what happens. Let's say that we look at the forces acting on the mass M. Here's the force due to gravity, which is just M times G, and here's the tension in the cord, T. So let's just assume for the purposes of discussion that T is bigger than mg so that the mass accelerates upward. Then we can write Newton's second law, F net equals ma, like this. Let's say that the net force is T minus mg, and that has to be equal to m times a, where we're assuming that a is positive in this direction. Whatever the direction it's accelerating, that's positive. So what that means is the tension then can be written as just simply m times a plus g, moving this term to the other side of the equation. So just to take an example, let's say that the mass is 50 kilograms. Let's say m is equal to 50 kilograms. Let's say that g is equal to 9.81 meters per second squared. And what we want to know is, let's say, for example, that the acceleration is 2 meters per second squared upward. What is the tension? Well, here it is right here. T is equal to the mass, 50, times the acceleration, a, 2 meters per second squared, plus 9.81 meters per second squared. And that works out to be 590.5 newtons. 590.5 newtons. That's what T is when T is greater than m and accelerating upward. Now let's say, for example, that A is equal to minus 2 meters per second squared, i.e. it's accelerating downward. Then what is the tension in the cord? The tension then is equal to 50 times minus 2 plus 9.81, and that works out to be, if you plug it in the calculator, 390.5 newtons. Quite a bit less. So as you accelerate downward, the tension in the cord is less and less and less. Obviously, if you accelerate downward at 9.81 meters per second squared, this term is going to be 0, and the tension in the cord will be 0, in fact. And that means that we have here a generalized equation that tells us what the tension in the cord is. But let's say we have a different situation. Let's say we have a cable that has a maximum strength, T max, of 600 newtons. The question is, what's the maximum acceleration, A max, that we can accelerate this object upward with and not break the cable? All that means is that we have to solve this equation for A and then plug in what T max is, and that'll give us the answer. So looking at this equation right here, I can write this as T over M is equal to A plus G, and that means then that A is equal to T over M minus G. If I plug in the numbers for that, 600 newtons is the maximum, and the mass is 50 minus 9.81 meters per second squared, and that works out to be 2.19 meters per second squared. And you can take a look at this original problem we had up here when it was accelerating upward at 2 meters per second squared. It was already up to 590.9, so this makes sense. Just a little bit more, and that would exceed the maximum tension that the cable could manage.